All right, we are starting lesson 2. Don't make me call you out. Lesson 2 is all about arcs and angles. So an arc is the side of a circle. So this right here is arc CF. And when you see this little thing, it's like an arc, like a rainbow almost, that means arc CF. Okay, so there's some important things you need to know about the different kinds of arcs. First of all, there is this thing called the central angle. A central angle is made up of a point in the very middle of the circle and two sides that go to the edge of the circle. So each one of these are central angles. These are central angles because their middle is in the very middle of the circle. Okay, now there's 3 different kinds of arcs. There's a minor arc, so I'm circling minor. A minor arc is any arc that is less than 180 degrees. Any arc that is less than 180. A major arc is greater than 180. But less than 360. And then the last one is a semicircle. How many degrees is a whole circle? 360. So a semicircle is exactly 180. So it is equal to 180. So minor is less than 180. Major is greater than 180. Most of the time, these minor and major arcs are going to be listed with a minor arc, like right here. This is GE. This arc is a minor arc because it's less than 180. So they use 2 letters to describe that arc. But if it's a major arc, like arc HG to C, if I were to say arc HGC, it has 3 letters, so that's most likely going to mean that's a major arc. So you have to follow it. Go from H to G to C. So you have to follow it all the way around. All right, let's practice. In exercise 1, how many degrees is a circle? 360. So if I want to find that arc, X, how would I do it? 360 minus all of those, right? And whatever's left is the degree of that angle. Okay, so did you do 360, subtract all that? And what was the angle? 80. Okay, good. So that means X was 80 degrees. And number 2, what does this square thing right here mean? 90 degrees. Yep. So, I know the whole thing's 360. Subtract 120 and 90 and you'll have what's left. Okay, so X was equal to 150 degrees. All right, in the next examples, we want to identify each as a major, minor, or semicircle, and then find the measure, how many degrees it is. So first of all, let's just look at this circle. If I put my finger right here, how many degrees is there? 180. It's 1/2, which is what? 180. Well, 44 is taken up. So can I find the other piece? 180 minus 44. So right here, that this is 136. Huh? Yes. Does this look familiar? If this is 44, what is this? 44. What are they called? But vertical. Vertical. So if this is 44, so is this. Yep, it is like a bow tie. And again, if this is 44, then this is 44. And if this is 136, then what's this? Very good. Y'all are awesome. All right, so let's look at each of these. Okay. Measure of BA. So look at BA right here. How many degrees is BA? Look up here. 44. Is that major, minor, or semicircle? Minor. So let's write it's minor, and it's 44 degrees.
Okay, so like before you can determine if they're minor or major.
You can determine that first and then decide, because you know if it's less than 180.
I mean, yeah, but we'll be not sure. You have to calculate first.
Then you could. Okay, CD. How many is CD, major, minor, or semi? Minor. And how many degrees? Okay, now we're talking about B, C, D. So you have to follow it exactly in the order that it's given. From B to C to D. How many degrees? 180. So it's a semi, and it is 180 degrees. What about BC? Just BC.
My fellow classmate doesn't understand.
Okay. So let's get back to 7. Let's go back to 7. It's asking me to find the measure of BCD. So I'm going to start at B, and I'm going to circle around till I get to D. But I have to make sure I pass through C. So I go from B to C to D. So whatever's in pink is the degree of this arc. Well, 136 plus 44 is 180. So I know it's a semicircle. Okay, now I only want to find BC. So take your pen, put it on B, and circle till you get to C. Well, I only went 136. So BC is a minor, and it's 136 degrees. Minor is always less than 180. Major is greater than 180. If it's equal to 180, it's a semi. A to C to B. I'm going to use a different color. Start at A. Here's A. I have to go all the way around to C. But look, okay, look. If I go this way, I hit B first. I can't hit B first. I have to hit C first. So I have to go the other way. A to C to B. Well, my goodness, I almost went all the way around the circle, didn't I? I went through everything except for 44 degrees. So it's quick. Yeah, I would do 360 minus 44, which is 316, so it has to be a major. And then what about AD? No, A to D. 136, which means it's a minor. Okay? Well, there's one more part, but it's not bad. So turn to the back. Alright, so what we just found was the degree of the arc. We found out how many degrees each one of these were. Okay? Now, we want to find the arc length. That means if I were to walk this edge of the circle, how many feet, centimeters, inches, etc. would I take? I don't want to know units. We walk in feet or inches. So there's a formula that you have to use to find the arc length. And this is your formula right here. This is the formula to find arc length, which is the distance of outside. So if you were to walk around here, how many feet would it take? This X in the formula stands for how many degrees are in the arc you're looking at. So in this example, they're looking at arc AB. Here's arc AB. How many degrees is A to B? 135. So that's what you plug in for X. So to find the arc length of AB, using our formula, X stands for the degrees, right, Alex? X stands for the degrees in AB. So there's 135, so that takes place of X, over 360 is always the same, times 2 pi, your radius, which our radius is 8. That's how you find the arc length. Now, when you're plugging this in your calculator, be very careful and make sure you use parentheses around your fractions. So 135 divided by 360 times 2 times pi times 8. So your answer is 18.85. So the distance of arc AB is 18.85 inches. Because they told us it was inches. Yes. Oh, no, not cubic, sorry. All right, let's practice. We want to find DE. Well, how many degrees is DE? 120. So to find the arc length of DE, take how many degrees it is. Well, from here to here, from D to E is 120 degrees. Alex, look up here. 120 over 360 times 2 pi, and it tells us that the radius is 2. So plug that in your calculator. I don't know what I got yet. I haven't plugged it in. I got 4.19. Is that what you got? 4.19, and then meters. Okay, the next one is talking about DEA. So starting from D, going to E, and then to A, how many degrees is this whole arc? This circle, or this square? Yes, that means 90. So your measure from D to A is 120. Right, Zoria? Put your head up. 120 plus 90. So to find the arc length, it's 210 divided by 360, 2 pi, but the diameter is 7. So what's the radius? No.
3.5.
3.5. Plug this in your calculator. Because the diameter is 7, so the radius is 3.5. 12.83 inches, right? In order for you to get your credit for your homework, I must see this formula. FYI. I'm so glad. Okay, let's do one more together. BC. From B to C, how many degrees is B to C? 45. So to find the arc length, I use 45 over 360 times 2 pi. But BE is 24 feet. So what's the radius? 12. Did y'all get 9.42? Okay, one more. One more, and then I'll let you start your homework.
Oh, I didn't get that.
What's the homework?
Do number 4, and then we'll start on your homework. You didn't get that? CBA. So you have to add 2 of them together. Do we know that? Do we know how many degrees AB is?
No.
Well, if I cover this up How many is left? How many degrees is this right here? The whole thing. 180. And if that's 90, then this has to be. So to find the arc length of CBA, you add 90 and 45. Which is, so that's your degree, 135 over 360. 2 pi times 3. Because DO is a radius.
Yep.
Seven 7.07 millimeters. Good job. All right, your homework. What I'm checking tomorrow. We're going to skip these last 4. Okay, it's the same thing. So your homework is this whole back page number 6. The whole back page. And you got a